Okay, hello everyone, and welcome to our presentation. Our title for today is Multi-Container Applications with .NET Core on Kubernetes. And we'll show you throughout the presentation an application developed for Hafslund, which is a demo application. So Hafslund is a power and grid company located here in Oslo, or in Greater Oslo if you want. And we'll show this demo application how it corresponds to the entire IT infrastructure and architecture of Hafslund. So this will be our agenda for today. So first, Ståle here, which is the Chief Technology Officer in Hafslund, will take you through the background and strategy of Hafslund. And then we'll further just dig a little bit deeper into the technical stuff. We'll show you a framework called Lunaform. This is something that Hafslund has created, developed on their own. It's basically consists of Terraform, which is an open source infrastructure as code, and Moonshine, which is also a framework developed for Hafslund. Moonshine encrypts application secrets and decrypts it on the fly in runtime when you start up your application. We'll go further into that later. Then we'll show you the development of an application from just starting to actually from scratch, starting to develop an application with the creation of infrastructure, coding, and stuff like that. We'll show you an Angular 2 client, and we'll show you a .NET Core REST API service. And finally, we'll deploy all of this as a multi-container application on Kubernetes. So first, just briefly about us. So I'm a consultant working for a consultancy firm called Compitas here in Oslo. I work mainly as an architect and developer. And if some of you want to reach me afterwards, you can either come up here and talk with me, or you can do it the more easy way and contact me here if you want. And Ståle will take it from here.
Yes, hello. So this title, Technology Chief, I've gotten from Magnus. I'm very glad of that. I think I'll show it to my boss. I'm also a developer and an architect. And I'm almost the only one that's employed in Hafslund. The rest are consultants. So we're looking, I'll just mention briefly, I think in the future we'll hire people. So if you... Yeah, okay. I'll say something about the background just briefly, just to say where we are, where we're coming from. And this is a slide I got from my boss, which and the point of this is to tell you that this business is over 100 years old, and for the first 100 years, nothing happened except that the net stations were progressively getting uglier. And then what they're telling that the next 5 years, that's starting 2 years ago, more stuff will happen in this business, I think worldwide than ever before, mostly because of regulation from the government. So the big driver right now is the AMS project, which is to put automatic meters in every home and every business in Norway. So that's like the driver for all this technology that we're now talking about. And the recent history when it comes to what we're like programming, it's like this. Before 2012, we just bought software. Nothing, not a single line of code was ever written in Hafslund. And that continued also after 2012, but then they were... we became Azure customers, but only having virtual machines in the cloud. So the modern world started for us in the middle of 2014 when we wrote our first line of code on the full .NET framework and with as Azure Cloud Services or Windows Services. And we also made a decision to try to go microservice. We didn't know that, that was our decision. So this has been going on until late or in the middle, a year ago about, when .NET Core came along, which we immediately fell in love with, started using. Now we're using .NET Core and those Docker, or in 2016 we used those Docker technologies. We of course still have what has now already become legacy code from 2014. And we also had this big milestone where we established a new team where Magnus is one of the key players in the end of the last year for the district heating business. So now we have 2 teams and we try to develop in the same way. And the first full application, container-based, we released in April this year. And we also, after that, have gone from Swarm to Kubernetes. So when I'm now talking about Kubernetes, we're just 1.5 months in having it in production. So we're still fairly new on Kubernetes. Quickly, this is very new for Hafslund. This is anchored all the way up to the top in our company now, which is very new, that we are going to develop everything that's core business ourselves. Or potentially, of course, have consultants, but we're going to have control. We're going to have the code in our code repo. And otherwise, we're going to buy stuff, but it's illegal to customize that. That's one of our main pains now, is all the stuff that's customized. And for us as developers, this translates to this when we are going to code. We want continuous integration and continuous delivery, and that's, I think, the essence of what we're trying to show you today. Is the way we are trying to do continuous integration and delivery. And for us, that means that infrastructure is code. It means you can deploy and everything. And what we'll especially focus on, because we made it ourselves, is the secure and hassle-free handling of secrets, which is one of the small but important things you need in order to get this flowing. Also, naming conventions and structure for code resources. That's also a thing we did. I should have had it in the timeline, because we started with Azure without a thought that everybody did whatever they wanted. We had subscriptions, resource groups, So me and my other colleague, I think we had this project where we went through and saved hundreds of thousands of kroners just by deleting stuff. Because we didn't have the naming conventions, didn't know what things were. Also mention, since we have this history of working on Azure, we know these platform as a service components on Azure. And we are already invested. So now when we started doing containers instead of old-fashioned cloud services, we are doing it in a stateless way. Because that's the history, and we, to be frank, don't know that much yet about state in directly in containers. But it has given us the ability to move easily. So we switched from Swarm to Kubernetes without any problem. We are also currently running on Azure for some stuff, for the utility part. But we, in the district heating, we're running on Google Cloud Platform, which is what we'll show today. So this statelessness made this very easy to move. .NET Core, I think the first time I saw it, we just fell in love immediately. I think in my mind, it must be the future of .NET. I can't see any way around that. So we jumped straight ahead and use it from June. I think it was June last year that the first version came. Which means that we are cross-platform. We have PCs, but we build on Linux and we run on Linux. It also means that we can leverage what we already know because we are .NET developers. And there has been some problems. I think it's getting better. The main problem is all the legacy assemblies and everything that don't run yet on .NET Core. So we had a long period, for instance, Event Hub, which we use a lot. There wasn't a library for it. So we had to write our more low-level protocol thing. And then we had that running for 1 month, and then the library came. So it's still early days, but I'm betting that this is the future. Quickly, you'll see this in demos, but we have this decided on this. We are very liberal when it comes to, we have subscriptions. We make subscriptions all the time. Every application is a subscription. This is for not the Docker part, but for every storage, queuing, all the things on Azure. We make separate subscriptions, and we use resource groups inside the subscriptions in order to have the different versions of the full application. So this is an approach we just learned from another big, probably the biggest Azure user in the Oslo area. They did this, and if they do it like this, we'll do it like this. So you just have to decide on some convention. And the main part here, very important, is that it's strictly forbidden to do anything by hand. So everything, when we have this inside subscriptions, is infrastructure as code. And then we have a playground subscription where you can try stuff, but then you'll be prepared that can be deleted in the next second. Yes, and that was the background strategy. Over to
Thank you. Okay, so now you have maybe a kind of decent overview of how the strategy is, what we're trying to achieve here. So now we'll dig more into the technical stuff. So I'll start off by showing you a demo of this Lunaform framework and how we start from scratch from, okay, we have to develop an application now. We start from scratch. We want to create some infrastructure, write some code, and we'll take it from there. Okay. So first, a little bit background about Lunaform. So it consists, as I said, of Terraform and Moonshine. So Terraform is this open source infrastructure as code library. You can contribute yourself. It has a lot of different providers included into the framework. And if you want to read more, you can go visit their webpage. Moonshine is our own developed framework in Hafslund. What Moonshine does is that it takes application secrets and it encrypts it with a key pair that you provide it. And it stores it in the implementation we have at the moment, which is a table storage implementation in Azure. And then we can refer to these secrets by an annotation language that we have created in Moonshine. So we never refer directly to application secrets. We refer to this annotation in our config files for our applications. So when we fire up a container containing our code, then Moonshine will go directly into the encrypted store and retrieve the values for us and decrypt it with the keys that we provide. So Lunaform is a combination of this, Terraform and Moonshine. So what Lunaform does in runtime is that it runs the Terraform apply command, which is Terraform's way of actually creating the infrastructure that you have written as code. Then Moonshine takes over, and the output from this run of infrastructure creation will be encrypted and stored into Moonshine. So all of this Terraform code and Lunaform stuff is checked into an own repository that we suffix with application. So for instance, in this case, we're going to create a demo application, which we just call demo. So then we'll suffix it with application, so our repository will be demo application. And here we store all of the stuff needed to create infrastructure, to deploy all our containers in order to run our application smoothly. So for instance, throughout the demo, you'll see Terraform files and Kubernetes files. We'll get into that soon. So we'll soon just jump right into a demo, and we'll show just a very small application. It's basically a front-end client where you can write in your name and click a button, and it will just register how many times a given name has clicked the button. And it will, of course, store it down to our API, which further stores it back into a table storage in Azure. So this is basically the architecture that you'll see. So we have this developer sitting in his or her local environment. And okay, so you start from scratch and you write some Terraform code because you want to test your entire integration of databases and stuff. So you have to write, okay, I need a table storage account in Azure, so you write code for that. And when you run this in Lunaform, it will create what you have said Terraform to create. And then it will take all the output and persist it in Moonshine as encrypted values. And we'll now have this down here, this demo application repository, where these Terraform files and Lunaform stuff will be located. So we'll just jump right into a demo. So before we go on, all of the demos that you'll see today are recorded videos, because then we know that it will actually work and there's no bugs or ghosts.
First take on everything.
Yeah, the first take, of course. Okay, so we'll just jump right into this. So, okay. Yeah, very nice codec here. Sorry about that. Okay. So now we're into the Azure portal of Hafslund. So what you'll see here is the first thing, technical thing we'll start off with is the subscription. This is the technical stuff that developers kind of take into consideration. So here we have an empty subscription for our demo application. So we have just called this ASA demo. And you can see here there's no resource groups yet, so because resource groups are basically a container for all your resources that you want to work on. So instead of clicking this create resource button, create resource group button, we'll of course create this automatically by applying Terraform. So we'll just go right into our demo application repository, which I mentioned previously. This is where all the infrastructure code and deployment code will be written. So here we're into an IDE. We have this source folder and Terraform folder. So at this moment of time, we just want to create a dev resource group for development because we want to test our entire integration. So here you can see we have the given Lunaform files that we need. We have the Terraform files. So now we're into the main Terraform file, which specifies what resources will be created. So you can see we want to create a resource group because that's basically a group for all our resources. If we don't have one, we can't create any resources to work on. And further, we'll also create a storage account, which is an account for storage, basically. So you can have blob storage, table storage, a bunch of different stuff. We'll have a table storage implementation here today. And we can also go into this variables file. And you can see the text I've highlighted here is basically a variable defined in the variables file. We won't go into this file today because it contains all of our secrets, so you won't see that today. So we'll just skip right into the output file, because this is very important, because as I mentioned previously, Terraform outputs what you tell it to output. So in this case, we want to output all the different stuff we need for our application to run, because we need it in our config file. But we don't want the actual secrets. We want the encrypted secrets through Moonshine. So this is what Terraform will output as plain text. So it will just output all of our secrets right into the console when we run it. But Lunaform will take all of this and encrypt it into Moonshine for us. So we can just go into our development folder for Terraform. So, okay, we just make sure that we're in this folder and we have these files. And now we can run Terraform in order to just show you the output of the Terraform run command. Usually we just run Lunaform right away, because Lunaform will take all of the output and encrypt it into Moonshine, and you'll never see the plain text secrets. But just in order to show you how it works, we'll just run the Terraform apply command first. So Terraform apply, we'll run this one. And this will usually take a little bit of time, so I'll just speed up a little bit. Okay, so now you can see it has created a storage account here, a resource group here, and our storage account name is here. So now you can see it's still creating our storage account. So you can see how many seconds have elapsed. 30 seconds. Should be done soon. Okay. So here is the output of Terraform. So you have this storage account key, which is basically our plain text storage account key, which we don't want anyone to know about. So what Lunaform does is that it takes this output, it encrypts it, and it stores it into Moonshine. So now we have run this Terraform apply command, and we didn't have any resource groups prior to this. So we'll just go right ahead and refresh, and hopefully we have gotten a new resource group, which we have. So we have now a development resource group in Azure for our demo. So we can go ahead and click into this, just to make sure that our storage account was created as well. So we'll just scroll down here. Okay, so here you can see we have a storage account, Hafslund demo dev, which was the name that we specified in our Terraform files. Okay, so far so good. So we can go back into here. And now we want to take all of these secrets. It's basically just one secret, but we want the other variables as well to refer to in Moonshine. Because let's say you have a production storage account and a test storage account. We want to version all of these secrets or variables, if you want, to a given environment. So if we say now we run in the dev environment, then our storage account name is Hafslund demo dev. If we run for production, it's Hafslund demo prod. So we just want to have all of these injected into Moonshine. So what we do then is that we can go into our Moonshine table storage, which is where our secrets will be encrypted. So this is just a Cloud Explorer into Azure. We have this config values table, and we can just refresh it to make sure that there are no entities here yet. No entities, cool. Okay, so what we want to do now is run Lunaform. And what Lunaform does is that it first runs this Terraform apply that we have just run here, but it will do it integrated into the Lunaform framework. But now that we have run it, it will just check that, okay, it has already been run, there are no changes, so it'll just skip that step. So now we run the Lunaform command, and now it calls Terraform, but nothing has happened there, so it won't run it. It's back from Terraform. And now it has taken all the application secrets from the output that you saw last time when we ran Terraform apply. And now it has taken the secrets and encrypted them into Moonshine. And now we can refer to them through this annotation language instead. So in our config files, we'll never know the actual secrets. We'll just know the annotation to the secret. You can also see that we have for the dev environment here because we version on environment properties. So now we can go back into our Moonshine store and we can go in and refresh. So hopefully we have some values here now. And we do. So we partition on application, and then we have a component for the application, which in this case is storage. And this storage also have a versioning. So you can see it's storage with a suffix dev. So that's for the development environment, obviously. So we have also stored this account key as a property with a property value, and our storage name, because names are also versioned if we want to version them. And in this case we have, because our storage account name had a suffix called dev. Okay. So now we have this encrypted secret, into Moonshine, which was the output of Terraform, the secrets that Terraform outputted. And these outputs from Terraform are also what we specified. So we have full control of that, what Lunaform stores. Okay, so that was our first demo. So I'll just try to illustrate what I've just been talking about these config files. So this is a typically default standard JSON config file in .NET Core. So in this case, we have just referred directly to our secret in this JSON file, which is stuff that many people do. But we don't want to do it, because if someone gets our code, then we're kind of in bad weather. So what we do in Moonshine, or through Moonshine, is to refer to it in this way, with the Moonshine annotation language. And when we refer to it this way, Moonshine will take and resolve our application secrets on the fly when we start the application. So how do we actually input this config file into our code? Well, this is the standard way of doing it in .NET Core. You just say add JSON file to our configuration builder, and then you build it. How we do it in Moonshine is basically just the same way, but with an extension method. So we have just extended the configuration builder to this. So now, instead of saying add JSON file, we just say set up Moonshine configuration with our config file. And on the fly, when we say build, it will resolve all our secrets, decrypt it for us, and we're good to go. And of course, we have to provide Moonshine runtime with our encryption keys and where the actual encrypted secrets are located. And we'll get to that soon. So then we can start injecting our secrets into our code. So in this case, you'll see a person repository, which is a repository over our table storage account, where we will store persons' names and how often they have clicked the button. So now we have all of these decrypted secrets from Moonshine ready to be injected into our person repository. So we just refer to them as this and inject them into our classes. So like this, and we inject them like this. Okay, so now we have our development infrastructure ready to go. It has been created. We have a storage account. We can start actually persisting some data. So this is what we had. This is where we left off. And this is where we want to get now. So now we want to start develop a demo service, which has its own repository down here. And we want to read and write to our created table storage account, or storage account if you want, because you can store many different implementations there. So we'll just jump right into it. So now we're into our demo service, which you can see here on the right. And now we're into the actual demo controller, which is our entry point for our REST API calls that we'll soon get to. So what we have here is that we have a get method for getting data, which is basically the names and how many times the person has clicked the button. And we also have post, because we want to take all the clicks and post them and persist the actual data into our table storage. And you can see here that we have injected this iPerson repository as a singleton. We saw how we resolved the secrets and injected them into the person repository, which is this class. So here we inject the actual secrets. The storage account for the table storage is in need of these parameters, storage account key and storage account name, which was the previous slide I showed you where we inject our secrets, which we don't have any clue what is. We just tell Moonshine to decrypt them for us. So we have this write person, we have this delete person, just basic repository operations that we'll soon refer to in our code. Actually, we have referred to it. I'll just show you. So now we're back into our app settings JSON file, which was the file that I showed you on the slide. So we have referred to our Moonshine annotation secrets. We don't know what they are. We just say to Moonshine, this is our secret. Please get it for us. Demo storage name. And of course, as we showed previously, we have this demo application, storage dev, and the account key and the name, which are encrypted. So, and now the kind of magical stuff comes into play, because some of you might now wonder, well, how do you know where to get the values from? How does it know how to encrypt it? You need to provide something, right? So, of course we do. So we specify environment variables in our running application. So Moonshine will take these into consideration and know what to do with them. So when we develop locally, we have this support for Moonshine properties files, which are the environment variables specified in a file that Moonshine recognizes. Usually when we deploy the applications to Kubernetes, these secrets are actually specified in Kubernetes as secrets. We'll get to that later. But now, when we work in our local environment, we can specify it through this Moonshine properties file, so we don't have to go into our system environment variables and change them. We can just sit in a file and change them. We can go towards multiple environments. In this case, we want to go to the dev environment. So all of this is specified here. So we have the Moonshine storage account key, we have the Moonshine account name, what table it is located in, and stuff like that. So this is kind of the configuration for Moonshine in runtime. So here are our secrets for encrypting and decrypting. So these were the same secrets that Lunaform used to encrypt the values and store them into the table storage. And it will also use these to decrypt it on the fly. So now we're into our...
One detail, that file is git ignored, right? So it's not checked in.
Yeah, that's very important. So we just have them locally. So now we can run our demo service. And in .NET Core, you just say .NET run. And the application is started. We can go into Postman, and we can just test that our API actually works. So we go to the localhost API demo. We can get it, send the request, and we see that we get no content. Well, obviously, we don't have any data persisted in the table storage yet, so that's kind of the expected reply. So we can start posting some data. So I'll go ahead and just post the name Ståle, because I like Ståle so much. So I'll just go ahead and click send. And OK, we get a 200 OK back. One click. We can send, no. We'll just do something random, and we'll go back. And we can go into get again. So now we have posted one time. And now when we get it, we get the expected value back, 200 OK, which is good. So now we can just go back and post Ståle some times, just to make sure that it's no magic here. It actually works as it should. So we click him 5 times. OK, we get it again. It seems OK. And now we can go into our table storage account. So this was our storage account that we created in the as a demo subscription under our resource group. And now we have these tables ready to go. Now we can refresh because we have created our table persons. And we want to, we can just go in. And this was the person's table name that we specified in our config file. So, and it's also the table name that gets injected into the person repository, which tells it where to store it. So we can go into this one, and you can see now it has persisted the data that we have sent into our service. We can just go ahead and post again. And we can go back into this one and refresh it. And OK, so it has one more click. So the entire integration, the service integration with our database now seems to work. So far, so good. So this was where we left off last time. Or just now. And now we want to create a client that will communicate with our service, the service that we just showed, in order to have a kind of better graphical user interface that the users can interact with. And this will be in its own repository demo client. So we'll just go back into a demo. OK, so this was where we left off. We had clicked Ståle 6 times. So the integration with the service and the database seems to work. So what we'll do now is we'll just stop the service from running. We don't want it to run now. And we can go into our client code that we have called the demo client. This is Angular code. So this is basically a client that will communicate with our REST API. So now we're into the demo client in our PowerShell. So what we'll do now is that we'll start this client through the Angular CLI. And we'll say that we'll run with the local environment. And first time is pretty slow, so we'll just skip up a little bit here. And I see that the codec is really... Do you get the green screen as well sometimes? Yeah. OK. Yeah, we'll just speed up here. So now you can see it's building stuff. It's going to deploy it to this localhost 4200 port. So we can soon start interacting with it. 92%. OK. So now it's good to go. We can go into our localhost and hopefully see our client running. OK, so this is basically our graphical user interface communicating with our service. So we can just try to submit a name, and we're now running in the local environment. We'll click the button. But of course, nothing will happen because we stopped the service previously. So we want to fire it up, .NET run again. OK. Now it's back up. And we can try to click the button again. We'll refresh it.
Worked last time.
Whoa, okay. So it just took a little bit time before it actually could communicate with our local service. Maybe our local computer was kind of crap. Okay, so we'll click it again. Okay, so now it seems to work pretty well. We can click it once more. Okay, so we'll just leave it at 5 clicks for myself. Okay, so now we actually have this client communicating with our service. It seems to, we can refresh, and hopefully we have Magnus there as well, which we do. So now the entire integration of the client, the service, and the database seems to be working pretty fine. So now we're kind of ready to let some users actually start using the application. So now we'll see how we actually take this local or development environment application and ship it to production, which we want to be as efficient as possible, which are why we have decided to use Kubernetes. And we'll get into the details there. So Ståle will take it from here and talk a little bit about that.
Yes, just a brief overview of Kubernetes. So what is it? It's the container, what they call a container orchestration engine. So there are mainly, you can choose between Kubernetes, or which is open source, comes from Google, or you have Swarm, or you also have something called Mesos. And this is the one we're using. So when you can run containers by yourself, or you can use this. If you use this, it handles a cluster of machines for you, and it also handles desired state. So you say what you want, and it tries to enforce it. So that if you say, I want 2 of these services, and one of them goes down, it will start a new one again. Runs on all the major cloud platforms, and it has a large community. So when you're working with Kubernetes, you are defining Kubernetes objects, and that's what you define in your YAML files. And what they are, as I mentioned, are desired state of what you want running on your cluster. What you want to run, and how each application should behave when it comes to scaling, upgrading, and fault tolerance, and those kinds of things. And there are several kinds of what we call objects. All of them are defined in the same way, and these are the most basic or important ones. The most basic one is called a pod. So you never refer directly to a container. A pod runs one or more containers inside of it, and it's a basic building block. And what it means is that if you have several containers inside of one pod, they are guaranteed to be co-located. So they're on the same node, same machine, and they can easily communicate with each other by localhost and other mechanisms. So that's the basic. But if you deploy a pod directly, that's the one thing that's not desired state. That's called a naked pod, and if it dies, it dies. Nobody's looking after a naked pod. So you have to define a replica set, which is if you define a pod within a replica set, then it's a desired state configuration, and it will handle it. This is also where you say how many copies you want. And then there's this higher level concept called a deployment, which is what you actually use. So you define a deployment, and that will be a combined definition of a replica set and a pod. You can do replica set directly, you can do pod directly, but the recommended thing is to do a deployment. So that's the one thing you do. And then now you have a container or several containers running inside of one or several pods, but nobody can contact them. So that's fine for some things. If you're, for instance, just listening to a queue and doing in the background work, and then you're finished. But normally or often you want to communicate with it, and then you have to define a service. Because a pod is ephemeral. It can die anytime. You should never refer directly to a pod. So if you want to talk to a pod, you have to make a service that refers to the pod. So service is an abstract way of talking to your pods, and also it's like an internal load balancer also. So if you say I want 10 copies of this pod, and you have a service defined for that deployment, then the service will automatically do a load balancing. And normally, the way we do it is that the service is, you could have several kinds of services. There are 3 types. The one we're using is called cluster IP, which means it's just, you can just talk to it internally on the cluster. So you have to be on the cluster in order to talk to a service. And then you have this thing, but you could define, if you're on a cloud provider, you can define it as what's called a load balancer. Then it automatically makes a Google or Amazon or Azure load balancer, which has a public IP, and you can talk directly to the service. We don't do that, and I think most people don't. What they do is they define what's called an ingress controller. And I will show you later, but that means you have one load balancer with one IP address talking to one container, which is a special one. And you handle routing by code internally inside. Also, you have configuration maps and secrets, which are more or less the same thing, which is for the whole cluster. So this is where we have all the secrets which Magnus showed you in that file. So that, for instance, for the production cluster, I can load up the secrets and not give him access. So he potentially doesn't know anything or can't actually find out what the secrets are. And there are many other objects. These are the most important ones. Load balancing, just so I mentioned, we are using this through, so there's this concept called an ingress controller, and when you, so that's a special kind of container, which I will have no idea how you can write yourself. You probably can, but there are 3 brands. You have Nginx, and you have this traffic, and HA proxy. So we, through just a random process, more or less, we chose traffic because it seems good. All of these, I think, are roughly equivalent, but it's French software, which is, it's open source, but French. So all the documentation is in French, which is refreshing. And they also have this, what I call a Norwegian letter in the name, which we think is cute. So then that's why we decided on this. Yes. So we have this one ingress controller. It's set up with a load balancer in Google, so we can reach it, and then we can, through code, do routing afterwards.
All right. So this was where we left off in the previous demo. So we had this client, this service working together with a database in our local environment, and we were pretty satisfied and wanted to ship it to production, basically. So what we'll go ahead and do now is that we create an automatic deployment build, and this build will just run our master code or our tag for the release, and it will run the Terraform scripts for production, which will create the production table storage account in Azure. It will take the output from Terraform, these secrets that we specify Terraform to output for us. It will encrypt these secrets and store them into the Moonshine table storage. Then we will deploy our application, our multi-container application, because we have this client, we have this service that we need to deploy, to Kubernetes on Google Cloud. And finally, we'll show you that the users can reach this application from the web and communicate with it. So we'll just jump into our demo again. So this is where we left off. And so Ståle mentioned these Kubernetes stuff, these objects, these kind of principles of Kubernetes. And what we'll show you now, firstly, is that we're going to build the image, the Docker container, for the demo client, and push it to the container registry in Google Cloud. So what we do now is we push queue a new build, and we want to run it for our release 1 tag. And usually this is automatic, but now we're just showing you that we queue up a new build ourselves, and it will start packaging, building the demo client, and it will ship it to the container registry in Google Cloud as a Docker container, or a Docker image if you want. So this build is running. We'll do the same for the demo service which has a newer minor release than the client. So this is 1.1.0, no hotfix yet. So it'll run the same steps, but for the .NET Core stuff. So it will do .NET Restore, .NET Build, it will do .NET Publish, and finally it will push the image to our project in Google Cloud, which is called this. And in Google Cloud, we have this container registry, which are all our packed images ready for deployment. So you can see we have this demo client image folder and the demo service image folder, which are basically containing all of the images for the demo service and the demo client. So here you can see we have 2 days ago, we have tested, develop, and master just to make sure that stuff works. But now we want to actually deploy it to production with a release tag. So we have the same for the demo client. It's 7 days ago. So these builds running in the background now will soon push these images to our container registry. So you can see here it's still building. So this usually takes a little bit of time. So we can maybe fast forward a little bit. So finally it will, you see, we have this push Docker images to Google Cloud. And here it actually
building the image.
Building the image, and it will soon just when the building is ready, it will push it to the container registry, which you saw. It's
now it's pushing.
Now it's pushing. Yeah. So it'll soon finish. Okay. So now the demo service have build succeeded, which is great. Everything seems to be fine. Okay. We can go into our container registry for the demo service. And the last one was 2 days ago up here. And we can refresh it, and hopefully we have a new image here now. Okay, so a new image was just now uploaded for tag 1.1.0, which is great. So the image seems to be fine. We can go back into our builds and go to the demo client build. And it seems that the build has succeeded there as well. So we can go back into the container registry for the demo client. And you can see the last one was a week ago. And we'll go ahead and refresh this one. Okay, so now we have this 1.0.0, and it was just uploaded. So everything seems to be in order here. So this is basically what we're trying to achieve now. So now we have pushed the images up here, and we also want it to deploy the actual images as running containers in Kubernetes. So we'll just go back into the demo. And Ståle will tell you a little bit about the actual technical Kubernetes files.
Yeah, so the result of the individual repositories is not the end goal. You merge to master, and then you have an image. It's not running yet, right? So that's what we do in this demo application repository. We have the infrastructure as code, and we have what's the topology of the containers that we're going to run for this multi-container application. So now we have this new folder in here called Kubernetes. And here we are defining deployments and services and ingress controllers. Sorry, ingresses. So, yep. Pass now. So this is a deployment. So as I mentioned, this is a combination of a replica set and the pods. So I'm saying here that if you look from the top, the first thing is here. So you see this is filmed later than because we have made a new version. But imagine that it was version 1.2.0 that we just pushed. So here we're referring to the image we just pushed. We're saying that we want one replica. And here we are specifying environment variables to push into the container as it started. And here you can, of course, hard code things. But here we're referring to these configuration maps. And do we have a secret here?
I think maybe it's further down, the secrets.
Play?
Yep.
Not so technical. Yeah, there were secrets down there that I've previously loaded up to the cluster as an entirety. So that means we have separate clusters for development, test, production. Some people do namespaces, but we don't. We do separate clusters. And then, since I want to reach this this one pod, I have to define a service, and that's here. Everything, by the way, in Kubernetes, it's labels and selectors. So you label things, and then if I want a service to refer to a set of pods, I have a selector that matches those labels. So it's like a soft label. Yeah. That's how you tie things together. I'm defining a service. I'm saying I want to call it demo service API SVC. That means if you're inside the cluster, you can now say HTTP demo service API SVC, and you can reach that service on port 5000, which is what I'm specifying. And it's a type cluster IP, which means it's internal, not reachable from the outside. But I want to reach it from the outside. So that's where you define an ingress. Yeah, stop. So we have an ingress, which automatically will register with the ingress controller, which was this French software, the traffic. So what I'm saying here is if anybody hits us, in this case, you can have lots of rules. In this case, it's a demo service after the domain, then route it to the service, which I called demo service API SVC. And there's also this path prefix strip, which means it will strip away the demo service. So we have, because if we just sent the address through a container, it wouldn't understand, because there's no controller in the .NET Core called demo service. So we stripped that away. So you can have all those sorts of rules. The nice thing with this is that it's in your code. You control it. You call your service provider once, gets them to set up the DNS to your 50.19, the IP address that you got from Google or Azure. And then you're finished, and the rest is you and your code. So now we're ready to go. So we have the same for the client. This is for the backend service. Yeah. That's yours.
Cool. So we have all of these Kubernetes files specified that we need to deploy it. And you can also see that we have this, we had this dev infrastructure as code for Terraform, Lunaform. But we now also want to have for production. So usually we stage it in a test environment first, but of course we don't have time to do that today, so we'll just ship it right into production. So we have these files here as well. So now we have written all of this stuff for deployment and for infrastructure as code for production. So we'll go ahead and push this stuff. We'll just push it straight into the master branch, which is kind of cowboy. We usually do pull request, of course, and stuff like that, and continuous integration, but we don't have time for that now. So we have specified this automatic deployment build, which starts, it has a trigger listening to the master branch. So now it has started a build on the master branch. So we can go ahead and look at this build, because we push the code directly into master. So usually it's a merge into master, but now we pushed it. So now it runs this Lunaform step over here for automatic creation of the production environment, which we need for production. It runs the Kubernetes deploy step, which is what we needed for deploying.
So currently it's running the kubectl commands.
Yes.
If anybody's familiar. So there are tools out there. We might look at them. We're just doing the G-Cloud kubectl commands directly.
Yeah, so we can just see here. So here it has run the deploy production script. So it has configured all this different stuff that we need in Kubernetes in our production environment. So everything seems to be okay now. And I don't know if the film actually... You can actually have bugs in videos as well, it seems. Okay, so I think it's running now. Maybe we have to restart it.
The whole talk?
Yeah, sorry about that. Okay, we'll try to just go ahead into here. Okay, so we're back here. Yeah, so this is where we left off. We saw the Kubernetes stuff. And we also run the Lunaform, Terraform stuff. So we now should have a resource group for production as well. We had this development resource group, but now if we refresh it, it should have created this production resource group, which it has. So now we have a production environment in Azure as well. And finally, it should have deployed it to our production cluster, which we can reach here. So we'll try to communicate with the demo client that has just been deployed. And so now we have this deployed application in the production cluster. So let's just go ahead and test that it works. So we'll just go ahead and write my name. We'll just, okay, so it seems to be working. We can just, I'll just fast forward a little bit because we're a little late on time, I think. And we'll just try to, okay, so it seems to be working. So now we have shipped the entire application into production. We have automatically created the infrastructure that we need, and all of this were done by the automatic deployment build that just triggered from our master branch when we pushed the code. So we can just see that it works as expected. Since it's in our production environment, we don't want it to be broken. Okay, so we can just click stall a little bit here. So it seems to be working fine. So it was pretty easy to just go from having nothing, starting from scratch, creating infrastructure as code, just coding a very simple service, a client, and just shipping it off to production through Kubernetes. Okay.
Injecting all the secrets without ever having to see it. So
yes.
we created the infrastructure and communicated the secrets, and we don't know what they are.
So this is basically where we left off. So this is the entire architecture for what we just showed you. And the summary is basically this. We run platform as a service in Azure, where we usually have our databases and storage accounts and application insights logging and stuff like that. And we run Lunaform for automatic infrastructure creation and application application secrets encryption. And then we usually use Angular for front-end stuff, and we use .NET Core for back-end services stuff. And finally, we deploy all of these as multi-container applications through Kubernetes on Google Cloud. So thank you so much for listening and showing up. We really appreciate it.
We might release some of this as open source, by the way.
Yes.
So keep...
we'll keep all of you notified. Okay, so if you want to get in touch afterwards, you can, of course, come up and talk to us and ask us questions and stuff, or you can reach us here if you want. So thank you so much.